Okay, today we're going to start working with segments, and we want to find segment lengths instead of angle measurements or arc measurements. All right, so what I've done is we have two chords here intersecting the circles. Okay, and the first thought, what I've done is use the highlighter to highlight triangles that were formed by those intersecting chords. What I want to know is, do you think that triangle AEB is congruent to triangle CED? Are they congruent? Or are they similar? I would say they're similar because they're definitely not the same size. Okay? They will be congruent because angle C intercepts arc BD, and angle A also intersects arc BD, so those angles would be congruent. The vertical angles would also be congruent. So those triangles are similar by angle. Remember that back in the first unit. We talked about what angles were congruent. Here, we could say that angle A forms arc CD, and so does angle B. So they would be congruent. We could say the vertical angles are congruent because all vertical angles are congruent. We could also say that angle C intercepts arc AB, so it would be congruent to angle D. So the triangles have to be similar. They're definitely not congruent because the yellow triangle is bigger than the green triangle, so they wouldn't be congruent. Now, the theorem says if two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the length of the segments of the other chord. So what in the world does that mean? Well, we know we have chords because CD and AB are inside the circle. And they intersect in the interior. They cross at point E, which is inside the circle. What does the word product mean? Product means we're going to multiply. So this is telling us to multiply the lengths of this segment. So if I look at EA would be the distance from E to A. And we'll multiply that distance times the distance from E to B. All right? And this theorem tells me that that's equal to the parts of the other chord. So that would be EC times ED. That's what our theorem's telling us. All right. We could have set this up in a proportion and cross-multiplied and gotten the same answer, but to me it's easier if we do it this way. So if I want to work this out, I'll look at my two chords. I see I have two chords. The first chord has segment lengths of 5 and 8. So that means I want to multiply 5 times 8 if I follow the formula. 5 times 8, because product means multiply. And that's going to be equal to the product of the other chord. The other chord is here. So it has lengths of x and 4. So that's going to be equal to x times 4. And now all I want to do is work it out. Well, I know that 5 times 8 is 40. And 4 times x is 4x. So to solve for x, all I need to do is divide both sides by 4. So I know the missing segment length is 10. It's pretty easy if you just follow the formula. Okay, this one's a little more difficult, but you still want to follow the formula. So if I look at this chord right here, the measurements for the segments are 9 and 4x. So I'm going to say 9 times 4x is equal to, and I'm going to look for the other chord, and here's your other chord. I have 4x plus 2 and 8. So I'm going to say 8 times 4x plus 2. Now notice I put that in parentheses because it's a binomial. It's more than one term. All right. So if I want to work this out, I'm going to combine my like terms. 9 times 4x is 36x. And I need to distribute my 8. 8 times 4x is 32x. And 8 times 2 is 16. A lot of people forget to multiply 8 times 2, so don't get caught doing that. All right, now all I need to do is solve for x. So I'm going to subtract 32x from both sides because I need to combine my like terms. So that's going to give me 4x equals 16. Then to solve for x, all I have left to do is divide both sides by 4. So I know in this case, x is going to equal 4. So all I have left to do is work it out. All right, now notice here that I have secants instead of chords. All right, I know it's a secant because AB goes outside the circle. It also intersects outside the circle. So we're going to have to follow a little bit of a different formula. All right, these triangles are also similar because B is in both triangles. It's in the yellow triangle and the blue triangle. And if you notice, angle C forms arc RS, or angle A and angle A forms arc RS. So since they both form the same arc, then those angles are going to be congruent. So the two triangles have to be similar. Now here's our theorem. If two secant segments share the same endpoint outside of a circle, notice it's got to be outside, then the product, that's telling you to multiply, of the length of one secant and the length of its external segment, external means outside, equals the product length of the other secant and the length of its external secant. So notice EA is outside the circle, so that would be your external part, and EB is the whole secant. Notice I'm not using AB, the chord inside, only the external part and the whole secant. And I also have to multiply EC is my external part because it's outside, times ED, which would be the whole secant. Again, I do not use CD inside the circle. So let's look at a couple of examples. Here I notice I have two secants. My first secant is here. The external part is 4. And the whole secant would be 4 plus x. And that, I notice if I follow my formula, is going to be equal to the external part of the second secant, which is 3. And the length of the whole secant, which is 3 plus 5. So if I work this out, I'm going to say, distribute my 4. 4 times 4 is 16. 4 times x is 4x. And I will go ahead and say that's 8. 8 times 3 is 24. 24. So if I solve this equation, I need to isolate the x, so I'm going to subtract 16 from both sides. The 16's cancel, so 4x gives me 8, and divide both sides by 4. So x has got to equal 2. So I found the missing segment length. Here's another example. Again, I'm using two secants. They meet outside. So the formula tells me to use the external part. So the external part is 4. And the whole secant is going to be 4 plus x minus 3. And that's going to be equal to the same thing on the other secant, which is the external part, which is 5, times the whole secant, which would be 5 plus x minus 6. Now what I need to do is combine my like terms inside my parentheses. So that's going to give me 4 times 4 minus 3 is 1. So that's going to give me x plus 1. If I combine my like terms over here, 5 minus 6, that's going to give me 5 times x minus 1. I need to distribute, so I'm going to distribute my 4 first. 4 times x is 4x, and 4 times 1 is 4. Same thing on the other side. 5 times x is 5x, and 5 times negative 1 is negative 5. So what I have left to do, and I'm going to take that up here, I'm going to say subtract 4x from both sides. I'm just going to copy that right here. 4x plus 4 equals 5x minus 5. If I subtract 5x from both sides, or 4x from both sides, those cancel. So 4 gives me x minus 5. And then to solve, I need to add 5 to both sides. So 9 equals x. So I've solved for x on that one. And that's the end of it. We're going to work some more on this tomorrow. Be sure to bring your notes so you'll have the formulas with you. And we'll complete this tomorrow.